Good afternoon, class. We are looking at pre-calculus practice test number 5, module 5, covering chapters 10 and 11. Here's chapter 10, analytic geometry. The second part, we covered the first part, and now the last part. Here's a pledge, as always. Small this. Before starting the exam, please read the following. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. In short, when we take the exam, we take the exam and no one else, and there is no resources available. In some instances, we may use scientific calculator. In specific cases, maybe a graphing calculator. All right, parabola. So first we start with the definition. A parabola is a set of points in a plane that are the same distance from a fixed point called the focus and from a fixed line called the directrix. As a result, a parabola is a set of points P for which the distance from F to P, distance of D stands for the distance, is the same as the distance of a P to D. It's the line called the directrix. That's by definition. So if you look at any of these, of course, this is a parabola that opens up, or for that matter, down. This is the parabola opens to the right or left, or with any where that it opens. When we look at the definition, in this case, the directrix is this one. In this case, is this one. In this case, is this one. Focal point is here. And from focus, if you pick any point, this distance, and you drop a perpendicular to its directrix, this distance must be the same. So if you look at this point, these two distances are the same. This point, these two distances, so on and so forth. So for example, in this case, this point P to the focus and this point P, you drop a perpendicular to the directrix, it's the same. Now, focal distance we want to discuss. So that is equal to that by definition of a parabola. What is the focal distance? The focal distance of a parabola refers to the distance from the vertex, the point where the axis of symmetry intersects the curve. So this point is the vertex. Here's the axis of symmetry that crosses to the focus along the axis of symmetry. This distance is the same from the vertex to the directrix. This distance is referred to as either P or A. In other words, if you look at this distance, if we call it A comma 0, this distance is A. If we call it P comma 0, it's P. I like to go with P because in algebra, we learned how to come up with the equation of a parabola. I'm going to discuss that in a moment. So I rather go with P is the focal distance. Now, this distance is the same as this one. By definition of a parabola. So this point has the same distance to the focus, the same distance to the directrix, and therefore the two must be identical. So if that happens, x equals minus a or x equals minus p. And to come up with the equation, you really want to have a rough graph and take it from there. I'll tell you what I mean in a moment. All right, parabolas have many applications in electricity, mechanics, and optics. Opens up, opens down. Here's the location of a vertex with H and K. Here's the location of a vertex with H and K. In this case, the axis of symmetry, x equals H. In this case, also x equals H. And the vertex as a specific location. Equations of parabola opening up or down. If you recall, we had a times x minus h quantity squared plus k. Vertex happens at h and k. The parabola opens up if a is positive and down if a is negative. The axis of symmetry has the equation x equals h. And in that case, the formulas ax squared plus bx plus c, or a times x minus h quantity squared plus k. Sometimes they call this the standard form, sometimes this one, but I'm going to call this one the vertex format because the vertex is given as h and k. But if you go with that one, h is minus b over 2a. So, and if it's given in this format, a and b and c are given, minus b over 2a, and plug it in and you can find the y coordinate. Now, what happens when it opens sideways? Equations of parabolas opening left or right, x equals a times y minus k quantity squared plus h. Now the vertex at h and k, the parabola opens to the right if a is positive and to left if it's negative. The axis of symmetry, now it's a horizontal line, y equals k. So take a look at this one. Vertex still at h and k, y equals k, and here's the formula. It opens to the right, and this one opens to the left. And the same vertex, the same equation as far as the axis of symmetry is concerned, but we want to be very careful with that. This is a negative. So x is ay squared plus by plus c, and a times y minus k quantity squared plus h. This is something we have seen already in algebra. The vertex, in this case, k is minus b over 2a, not h. Why is that? When we are looking at this format, it is quadratic with respect to x. So its h is minus b over 2a. But this one is quadratic with respect to y. Therefore, k is minus b over 2a, and you plug in and you find h. Now, so as we mentioned, parabola opens to the right, a parabola opens to the left, that's sideways. So equations of a parabola where the vertex is at 0, 0. The focus is that A0, I'd rather go with P0 if you will, because this distance is a focal distance. And x equals minus A is positive, and we say y squared equals 4ax. I'd rather go with 4px because of the fact that we used A with the format that was mentioned in algebra. When you look at this one, it opens to the left, and the focus is, in other words, inside the parabola. That's why it's minus a comma 0 or minus p comma 0. This distance is p, this distance is p. And x equals a, I would say x equals p. And so the equation becomes y squared equals minus 4ax. And as I mentioned, I'd rather go with p. In other words, I prefer this one. In some texts, they go with a. In some texts, they go with p. I'd rather go with p because we use a for the other format. So the vertex is at 0, 0. X equals ay squared. That is the format that we learned in algebra. Okay, a is positive, opens to the right, negative, opens to the left. Now, with the p, I'm going to say y squared is 4px, or y equals minus 4px. This is the format I like to look at. Now, when it opens up and down, okay, focus is at 0a. In this case, when it opens up, the focus is inside. I would say 0p. And y is, the directrix is below that. That's why y equals minus a. I would say y equals minus p. And then x squared is 4ay or 4py. When it opens down, focus at 0 minus a because it's inside. And the directrix is above it. That's why the equation is y equals a. And then x squared equals minus 4ay, or as I said, minus 4py. I prefer that format. So the vertex is at 0, 0. Y equals ax squared. This is what we learned in algebra. And now a is positive, opens up, negative opens down, and x squared equals 4py. Compare them to this. X squared equals 4py for this one, minus 4py for this one. This is a better method. Again, I'm going to remind you, this is the focal distance. P or A. So what is the focal distance, everybody? This distance. Okay. Which is the same as this distance from here to here. Okay. And because we don't want to mix things up, we are going to go with P when we want to go with this format. Now, the relationship between A and P, this A and this P, is that 4AP is 1, or A is 1 over 4P, or P is 1 over 4A. So I'm going to add this part. Y squared is 4PX, or minus 4PX. X squared is 4PY, or minus 4PY. The relationship is P equals 1 over 4A, or A equals 1 over 4P, because of the method that we learned before. Now, lattice rectum. What is lattice rectum? Let's discuss that terminology in the case of a parabola. Okay. So the focus, if you draw a line perpendicular to the directrix, it cuts the parabola at 2 points. The distance from this point to this point, it's lattice rectum, and it's equal to 4 times the focal distance P. In other words, lattice rectum. The lattice rectum of a conic section is the chord, the line segment through a focus parallel to the conic section directrix, and it's equal to 4P. The distance is 4P. The length of the parabola's lattice rectum is equal to 4 times the focal length, 4 times P. Notice I rather use P. So its end points lie on the curve. So like I said, this is the focus. Draw a parallel line to directrix. It cuts it here and here. This distance is the lattice rectum. So because in this case it's open to the right and the focus has coordinates 2, 0, the 2 points have coordinates, x coordinates equal to 2, and you can figure out the y coordinates. We will go over that in a moment, but it's easy to see. Now, in this case, just for the sake of argument, focus has a specific, coordinates x, comma, y, and you go to the right and to the left, and every point that you see here and here, they must have the same y coordinate as f. So depending on the drawing, you can figure out which coordinate, x or y, is the same as the coordinate of the focus. All right. So by definition, we want to prove this. By definition, the distance d from the focus to any point P on the parabola is equal to the distance from P to the directrix. So this distance is called the focal distance, and it's equal to this distance. That makes this distance equal to 2P. So P and P. This is 2P, and therefore this is 2P. And so is this one 2P, and they add up to 4P. The entire distance from this point to this point must be 4P, and that's the proof. Very simple. Now, a warm-up example, I want to look at what we did in algebra. We want the following function, f of x equals x squared minus 6x plus 8. It is also given in this format, x minus 3 squared minus 1, the vertex format, so you don't have to really calculate the vertex is given. Otherwise, you have a choice. X equals minus b over 2a, find the x coordinate and then plug it in, or do complete the square. Determine which way the graph opens, find the vertex, axis of symmetry, draw the graph, find the domain, and range, all of the above. So we want to discuss this with detail. So first and foremost, A is 1 and it opens up. The vertex is located at 3, negative 1. So it makes the axis of symmetry x equals 3. And I hope you see that, for example, the y-intercept is just this one. Remember, the y-intercept set x equal to 0. And because it's given in this format, just 0, 8. But if you want the x-intercept, you set y or f of x equal to 0. That means you set this one equal to 0. And it's better to set this one equal to 0 and factor it into x minus 2, x minus 4. I'm going to assume everybody can see that you want two numbers, the product is 8, the sum is -6. So -2 and -4, and that results in x equals 2, x equals 4. X equals 2 means 2, 0. X equals 4 means 4, 0. So we have those pairs. Now, let's write the summary here, everybody. So 0, 8 we have, 2, 0 is this one, 4, 0 is this one, 3 minus 1 is the vertex. Now I'm going to discuss this in a moment, how we arrive at it without really having to calculate. So we graph the line x equals 3, that is, and by the way, that's the y-intercept, x-intercept, and so forth. And so we have those pairs, okay, the vertex is located at 3 minus 1. I start with that. Then we have the y-intercept of 0, 8. Then we have the x-intercepts of 2, 0, and 4, 0. Now, I want to discuss the axis of symmetry. According to the axis of symmetry, the left side and the right side, they can be identical with respect to the axis of symmetry. That's what it means. So in other words, if you start from the axis of symmetry and you go the same amount on both sides, that should work out. So if this one is on the graph and has coordinates 0, 8, and this one is 3, that means this distance, everybody, is 3. So if I go the same distance 3, I must have another point, and therefore that point must have coordinates 6, 8. And that's the graph. Now, the domain for any parabola that opens up or down, it's all real numbers, negative to positive infinity. The range depends on the location of a vertex. Because it's -1 and opens up, -1 to infinity. So that's pretty straightforward, everybody. And this is what we had learned before. There is really not much to it. And by the way, uh, infinity is a concept class, so it's always parentheses. -1 is included, therefore bracket, but infinity, of course, is not. Now I'm going to look at the same question, and I'm going to add what we just discussed in this section. So first of all, here's the graph, here's the function, here's the vertex, everything that we found from the previous page, and A and so forth. The vertex opens up, intercept, you name it. So this is information from before. Now let's see what it is we want to add, because I want to make sure that this concept is discussed, including the focal distance and so forth. All right, we said the relationship between P and A is that P is 1 over 4A and A is 1. So 1 over 4A, 1 over 4 times 1, or simply 1 over 4. Now, the focus, just so focus is somewhere inside here, somewhere here. Okay. So that means if we go back to the vertex, which has coordinates 3, -1, all we have to do, add the focal distance of 1/4. So 3 remains the same. So this is 3. Any point on that is 3. But we go up by how much? So look at the y-coordinate. We're going to go up by 1/4. We're going to add 1/4. So F has coordinates 3. So we are going to add P. 1/4 and -1 is -3/4. And again, it's almost hard to, show it, but you get the picture. So that's your focus with coordinates 3, -3/4. Now, the directrix is this line, the line below it, everybody, right? So you have a parabola opens up, the focus is inside, the directrix is outside, it's a horizontal line. So it has the equation y equals something. So let me actually draw it and then I'm going to. So I don't know the answer yet, but I know it's y equals something. Also, I know this distance must be the focal distance, right? So I look at the y coordinate and I notice the y coordinate of the vertex is -1. I have to come down by a focal distance of 1/4. So -1 minus 1/4 is -5/4. So of course, I'm going to erase my work because it looks terrible. So this is the line. The equation y equals -5/4. Now, let's discuss latus rectum. Latus rectum means you connect them and you want this distance. So first, if I look at these points, this one and this one, they have the same y coordinate as the focus, -3/4. So the y coordinate is -3/4. What is the x coordinate? Well, you can put it into this equation or that equation or this equation. If y is -3/4, that means y. That means f of x. You can find x. And I'm going to leave it for you to find it, but I'm going to give you actually an easier method, a faster method. So this one, you plug in the y coordinate, you can find x, and x has 2 coordinates. One of them is 5/2, one of them is 7/2. So that means this one is 5/2, this point, -3/4, and this point, we talk about this point, 5/2, -3/4, and this one is 7/2, -3/4. Okay. Now the second method is that we know the focus is located at 3, -3/4, and we know the y is not going to change. So all we have to do from the focus, we go to the right and left by 2 times the focal distance. So add ±2 times p. P, the focal distance is 1/4. 2 times that is 1/2. So we are going to the x coordinate and subtract 1/2 and add 1/2. If I subtract 3 minus 1/2, I get 5/2. 3 plus 1/2, I get 7/2. So add ±2p, which is ±1/2 to its x coordinate. And we get the 2 pairs. I hope you see how easy it is to find those 2 points. Let me erase my work. So I'll go up, and now you can easily see the graph. So that makes it a lot easier, I believe. All right, identify the coordinates of the vertex, the focus, the length of the lattice rectum, and the equation of the axis of symmetry, and directrix, graph the parabola. All of the above, reminding you of 2 formats. the algebra that we looked at, and with respect to the focal distance, y squared equals 4px, and so on and so forth. In this case, y minus 2 quantity squared is 4 over 5x plus 4. You can put it in the same format as algebra or not. By the way, if it has it doesn't have 0, 0 as the vertex, it's y minus k quantity squared equals 4px minus h. Okay, so you see that next to x is plus 4, so that's minus 4. Next to y is negative 2, so positive. So minus 4 comma 2 is the vertex. And it opens to the right because 4 over 5, it's positive, okay, and it's quadratic with respect to y, okay. And so, or you can put the 4 over 5 to the other side, is 5 over 4. So minus 4, so we go 4 to the left and 2 up. That is the location of a vertex. Now, if this is the location of a vertex, to help us understand what's going on, and it opens to the right, and I'm going to graph something which is wrong, but I want to give you an idea. So the graph should look like, okay, something like that. This is not to scale. Somewhere here, I don't know where, it's going to be the focus. Somewhere here must be the directrix. And I'm graphing this so I have an idea what to do, okay? Now, because it opens sideways, the axis of symmetry, okay, has the equation y equals 2. So this is 1 and 2, so that's the line, okay? Now, this one is A, so 4p is 4 over 5, and p is 1 over 5, or 0.2. Okay, so if this focal distance is 0.2, and again, what I have is not to scale. This distance is focal distance, and it's 0.2, we found out. Then from the focus, you go to the right by focal distance of 0.2, and you get the point that is the focus. You go to the left, and you make up the vertical line, and that is your directrix. So starting with the vertex, okay, and we want to go to the right inside. We're going to go to the right by 0.2, so we're going to say minus 4 plus p, and that gives us negative 3.8 comma 2. Now let me erase my work. So that's this point, and we already know it opens this way, and this is the line. And for the directrix, is the same distance on the left side. So if you look at the x coordinate, subtract the p, so minus 4 minus p becomes x equals minus 4.2, the directrix. And you can graph it. It looks like that. Now, so we got everything. Latus rectum is a line segment parallel to this directrix. So it's this one. And again, reminding you, the latus rectum of a conic section is the chord through the focus parallel to the conic section. 4p equals 4 over 5, or 0.8. That means the distance from here to here. This distance is called the latus rectum, and it's equal to 4 times p. Now, we can locate those pairs, and remember, the focus is located at negative 3.82. So if you look at these 2 points, they have the same x coordinates. What is their y coordinate? Well, go back to the y coordinate, which is 2 of the focus, and go up by 2 times p and go down by 2 times p, okay? If p is 0.2 or 1/5, then 2 times that is 0.4 or 2/5. Therefore, lattice rectum endpoints, you have a choice. X is negative 3.8, put it into the equation, find the y, or the second method, which is easier. Given f with coordinates negative 3.82, x is minus 3.8, and add plus minus 2p, that means plus minus 0.4. So if I add 0.4, I get 2.4. If I subtract, I get 1.6. Those are the coordinates, negative 3.8, 2.4, negative 3.8, 1.6. Those are the coordinates. All right. Use the graph of the parabola to determine the equation in standard form. Bear in mind, this is the vertex, the focus, and this distance is the focal distance. This is your directrix, so on and so forth, And if we want to go with the format that we learned here, x squared equals 4py, or x minus h quantity squared is minus 4p times y minus k. How do we know it's negative? Because it opens down. So the vertex and the focus are given. So those two pairs. So the vertex is at negative 3.5. It's given. We are just reading it. And the focus is at negative 319 over 64. It's given. And the distance between the two, this distance is the focal distance, or p. So this distance, because they have the same x coordinates, would be the top 5 minus the top y minus the bottom y. So 5 minus 319 over 64. And you multiply 5 by 64 minus 319, and you get only 1. Now we go to this equation and we say x minus h, that means x plus 3 squared, minus 4 times p, minus 4 times 1 over 64, y minus k makes it y minus 5, and of course, minus 4 and 1 over 64, the product is negative 1 over 60. Just quickly, a second method, we would go with y equals a x minus h quantity squared plus k. This is the general standard when it opens up or down. The vertex is minus 3 comma 5, so we're going to write a times x minus minus 3 or plus 3 quantity squared plus k, which is 5. And a is 1 over minus 4p because it opens down. One over negative 4 times 1 over 64. This is negative 1 over 16, and it becomes negative 16. And so now we have everything we plug in, replace the a, and we get y equals minus 16 times x plus 3 quantity squared plus 5. So, and I hope you realize this one, everybody. This is the same as this one. We can go from one format to the next. I hope you see that they are identical. The two equations are identical. So all you have to do, multiply both sides by negative 16, and then move the negative 5, becomes plus 5. So it's another way of writing it, not a big deal. Okay. Given the function expressed in standard form, in this case, f of x equals a times x minus h quantity squared plus k. Normally, we call this the vertex format. It depends on the text. And find the x-intercept, the y-intercept, the vertex, find the axis of symmetry, graph the function. They are not asking for anything else. So the very first thing we do, uh, uh, we are going to put this in vertex format by putting these two together. You have two choices. You can say x is minus b over 2a and find the h and then plug in, find the k. Or do completing the square. The way we do completing the square is that we take these two together and we take the 2 out. Now I want to complete this square here, so let me use a different color. So over here, b is 2 divided by 2 is 1, squared is also 1. So I need to add 1 here. To add 1, everybody, means I'm adding really 2 times 1 because of these two. If this was 5, I'm adding 5 times 1, whatever this number is, don't forget. So if I'm adding 2, I'm going to subtract 2 to undo it. So important to understand. 2 times 1 is being added. Therefore, I'm going to subtract. So this is 2 times x plus 1 quantity squared. 6 and minus 2, they add up to plus 4. The vertex is located at negative 1, 4. So we go 1 to the left, 4 up. Because A is positive, which is 2, it opens up. So it goes just like that, just to give you an idea. And right away, there is no x-intercept. And the proof is actually simple. If you calculate b squared minus 4ac, now we go back to this one, everybody. Let me erase my book. This one. B is 4. So 4 squared minus 4 times a times c, you get negative, and that means there are no real solutions. There are two imaginary solutions, and real solutions correspond to what? To x-intercepts. But it's easy to see that it has 0, 6 as the y-intercept, and vertex is at negative 1, 4. X equals minus 1 is the axis of symmetry. So if this is the axis of symmetry, this distance is 1, everybody. If we go the same distance, 1 more, then we have a point here. And if this is 0, 6, we go this way, and it becomes negative 2, 6. This is by the axis of symmetry, and it opens up. And it looks like that. Very straightforward. They didn't ask for anything else. I highly recommend you try to find other things such as focus, focal distance, and everything else. That would be a good practice. Now, identify the graph of each equation. So I'm having all of them next to each other, and we want to figure out what they are. Okay. So, for example, this one is a circle, and why is that? I want to remind you, x squared plus y squared equals r squared is a circle centered at 0, 0. X squared over a squared plus y squared over b squared equals 1. It's an ellipse centered at 0, 0 again, and hyperbola x squared over a squared minus y squared over b squared equals 1. So how do we know it's a circle? Because x squared and y squared, that they have coefficients that are identical. Both x squared and y squared are there with equal coefficients on the same side of the equation. That's how you figure it out in a split second. If you want to prove that, you have to put that in standard form. Okay. What about this one? It's an ellipse. How do we know that? Both x squared and y squared are there with different coefficients and the same sign on the same side of the equation. So that's how you know this is the case. What about this one? We are going to bring this one to the same side, and it's a hyperbola. When they're on the same side, they have different signs. Both x squared and y squared are there with coefficients that have different signs on the same side of the equation. So here's the synopsis of how you know what happened. Now, the synopsis of that is this. When both x squared and y squared are there, and they're on the same side, identical coefficients gives you a circle, different coefficients, same sign gives you an ellipse. But if they have different signs, one is positive, one is negative, doesn't matter which one, it's a hyperbola. That's the synopsis of what we just covered on this page. Of course, you can put it in standard form to prove that. Determine whether the graph opens up or down, left or right. And first of all, those are parabolas. There's only one quadratic variable. That means you either have x squared or y squared, not both. Okay. What are the equations? Y equals x squared plus bx plus c, or a times x minus h quantity squared plus k. This opens up or down depending on the value of a. And ay squared or by plus c, x equals that, or a times y minus k quantity squared plus h. This opens sideways. So this is quadratic with respect to x, and a is negative, so it opens up or down. Negative makes it down. So a is negative 2 less than 0, opens down. This one, it opens up or down because of the x squared. However, the value of a is 1, and it opens up. This one, it opens sideways because of y squared. You look at the coefficient is positive, it opens to the right. So very straightforward, everybody.